Guten Tag, my curious friends. I see you're still eager for riddles. Today we tackle the biggest one, quantum entanglement. It's the phenomenon that made me call out quantum mechanics for being, well, spooky. And yes, in the end it was I who was a little bit wrong, but it's still the most fascinating mess in physics.
Part 1. Intricacy and the spooky connection.
Let's start with the name. Entanglement. It's a word coined in the 1930s to describe a bizarre state where two particles, which we call entities, become so connected, so intricate, that it's impossible to tell where one ends and the other begins. They become part of an interconnected whole. Think of them as two halves of a single quantum personality. Even when they fly arbitrarily large distances across space, hundreds of kilometers, that bizarre connection, that quantum connection, persists. And this is not just philosophical talk. This is a genuine state of matter on which whole technologies like quantum cryptography are being built.
Part 2. The EPR Paradox.
Now in 1935, I got involved. With my brilliant young collaborators Podolsky and Rosen, we wrote a famous paper, the EPR Paradox. The logic seemed ironclad to me. We said, look, if entanglement is real, it leads to a contradiction. If these two particles are so far apart, and let's say Alice and Bob measure a property on one of the two particles in their respective laboratories. If Alice measure a particle property in his laboratory, Bob instantly know the result of the measure of the property of the other particle in his laboratory, instantly, faster than light. My conclusion was this. Since nothing can travel faster than light, that is correct, thank you, general relativity, there must be some preset instructions or hidden variables already inside the particles, determined in the past when they were together. Therefore, the spooky action isn't spooky, it's just a common cause. My hypothesis was that spatial separation must imply experimental separation. The particles should become independent. I was wrong. The universe is clearly not obligated to conform to the sensible expectations of a physicist. Are you enjoying the video? Subscribe to the channel, leave a like, and drop a comment below. I'll personally respond to you. Hit that subscribe button. You'll hear plenty more mind-bending stories like this one. If you'd like to create a video like this one, take a look in the description below. You'll find the link to the software I used. Purchase it from that link if you want to support Rock's blog Science. The whole argument was philosophical until a clever gentleman named John Bell came along in 1964. Bell and later Clauser, Horn, Shimoni and Holt, CHSH, wrote down a bizarre-looking inequality.
Part 3. The referee and the line in the sand.
This Bell's inequality is like a mathematical referee. It takes all those possible measurements, the 4 possible joint experiments Alice and Bob can do, and combines their results into one number, S. If your correlations are ordinary correlations, the kind that can be explained by a common cause in the past, like 2 pieces of an exploding object, your result must be less than or equal to 2. This is the limit of classical reality. But if you have quantum correlations, the genuinely entangled ones, you can violate this limit. Experiments, like the famous ones by Alain Aspect in the 1980s, showed the universe gives a number much higher than 2, up to about 2.4, sometimes even reaching the theoretical maximum, the Tserelson bound, 2 SQRT, 2.88. The evidence is in. This violation proves that these correlations cannot be explained by any cause that occurred before the measurement. They are not independent. They are not separate.
It's a real mystery. Why?
So the mathematicians tell us entanglement is real. The inequality is violated. Our 2 little quantum particles miles apart are definitely not independent. But you, the audience, and frankly I, the brilliant physicist, still ask the crucial question, why? What is the mechanism? The usual answer is, it's quantum mechanics. It's weird. Live with it. But I prefer to understand, to figure out how these quantum correlations differ from the ordinary correlations you see every day. Before to proceed and going deep in the understanding of quantum entanglement, do not forget to subscribe, like and comment, and give a look in description.
The water tanks experiment.
This is where a clever Belgian physicist, Diederik Ertz, gave us a massive clue back in the 80s. He invented a macroscopic system, a system you can actually see that can violate Bell's inequality. No quantum particles, no photons, just water. We put, say, 20 liters of water into 2 connected tanks. Alice and Bob, far apart, have 2 options for measurement. Measurement 1, the siphon. They each try to siphon out water. Since the total is 20 liters, if Alice siphons more than 10, positive, Bob must siphon less than 10, negative. The results are always anti-correlated. Measurement 2, the color. They look at the water's color. Since the water is clear, both always get a positive result. If you plug these perfectly correlated and anti-correlated results into the CHSH inequality, the answer isn't S or 2. No! This simple non-quantum system can achieve the maximum algebraic value, S4, a maximal violation.
The contextual revelation.
How is this possible? The water tanks are big. They're not quantum. This shows us the true difference. In the old view, the one I preferred, the correlations had a common cause in the past, like that exploding fragment, or this ball's hitting between themselves. The correlation comes from the momentum conservation. But here, the cause is contextual. The correlations are generated at the moment of measurement. When Alice and Bob start their siphons, they are actively breaking the symmetry of the single interconnected water system. They are forcing the water to separate into 2 measured quantities at that very moment. The act of measurement creates the cause of the correlation. The key is the connection. The water is flowing through the pipe. The systems are not separated. They form a single interconnected system.
The hidden connection.
Now, let's take this macroscopic lesson and apply it back to our tiny particles. When 2 electron spins are entangled and miles apart, we can imagine a connection exists between them. The big difference? With the quantum systems, we can't see the pipe. The connection is invisible in the space-time theater we love so much. This suggests the link, the entangling element, is hidden, or is something that apparently we cannot measure. The deepest mystery of entanglement is not spooky action at a distance in space. It is the existence of connection elements that lie outside of space and time as we know them. When Alice and Bob perform their joint measurement, they are simply forcing this connection to break, and that contextual break produces the correlations we observe. This suggests that the description of the nature of space and time particles and forces should be rethought. Entanglement is the prime example where the usual structure of space-time description just fails. But I have some ideas to reconcile quantum entanglement with space-time. Maybe I found those famous hidden variables from they come from. I cannot tell you all at once, of course. So, join the channel and stay tuned for new revelations. Do not forget to like and comment. So the universe is even stranger than I thought. Not only is it non-local, but it's held together by non-spatial connections that only reveal themselves when we try to look. A beautiful complication. So, what's the real mystery here? It's not that information travels faster than light. It doesn't. You can't send a message with entanglement. The true lesson is that the universe is non-local. It refuses to be described as a set of separate, independent parts. The quantum reality is one where distance, that great concept of mind from general relativity, is somehow an illusion to an entangled pair. They act as one, defying the separation of space. A bizarre and beautiful reality. Now I need a coffee. This whole spooky business still gives me a headache. Did you enjoy the video? Subscribe to the channel, leave a like, and drop a comment below. I'll personally respond to you. Hit that subscribe button. You'll hear plenty more mind-bending stories like this one. If you'd like to create a video like this one, take a look in the description below. You'll find the link to the software I used. Purchase it from that link if you want to support Rock's Blog Science.